Hi, all of you. Let's begin our session slowly so that others will join meanwhile. Okay, fine. Yesterday we have discussed the concept of orchestration. Orchestration means the process of management of containers. Okay, in general, orchestration is it's a different meaning, but specific to Kubernetes, Kubernetes is a container orchestration platform. So orchestration means in general management. So in container orchestration, what we do is this Kubernetes tool will orchestrate the containers which are created by the Docker. And we have seen that the Kubernetes architecture consists of control plane or the master and the nodes. And master consists of components called API server, which acts as the entrance to the Kubernetes cluster, and the scheduler schedules the pods on the nodes. Controller manager, we have different kinds of control manager like replication control manager, node control manager. All those things will bring the cluster to the desired state in case of any failure. And etcd is a database which stores the state of the cluster in key value pairs. Coming to worker nodes, every worker node will consist of container runtime, that is Docker in our case, and a kubelet, which is the agent of the control plane on the nodes, and every node will also have kubeproxy for networking. And in Kubernetes, the smallest deployable unit is pod. A pod can contain multiple containers as well. Okay, so that means a pod can have single or multiple containers based on the need. Now, we will interact with the Kubernetes cluster with kubectl, which can be downloaded with the command that I have provided here somewhere. Then we have to set the environment variable path for that. Otherwise, you can directly copy that to system32. Then you can use the kubectl client to interact with the cluster. And we have another way to interact with the Kubernetes cluster, that is user interface, which we do not use at all, either in the real time or in our classes. Then let's try to create Kubernetes cluster. And if you see at the macro level or at the higher level, we have the cluster. Every cluster will consist of multiple nodes. Inside nodes, pod will be there, and pod is nothing but an abstract layer over the container. And a pod can have multiple containers as well, but here we are showing only one container, and inside the container application will be running. So in Kubernetes, the smallest deployable unit is not container, but a pod. Then we have a tool called Minikube, which you can use to practice in our local, but I don't recommend that. It's a single node cluster only, but I always go with the things which we use in the real time. Okay, if you want to learn how to install this, very simple steps, you just have to use this, and Minikube start command will be there. And before doing this, Docker should be installed in our machine. This Minikube can be installed in Windows and Linux, anything it is there. Okay, that's fine. Now let's dwell into how to create Kubernetes cluster in AWS. Some way the order was changed in the document. So I will directly go to the page where the steps to create the Elastic Kubernetes service in AWS is there. Here it is, very long. So first, we are going to create EKS cluster. And you may not have the knowledge of AWS for this. I will show every step, but good to have the knowledge so that you will understand the IAM rules and the EC2 instances, the other things which are related to this service. But if somebody wants you to bring up the EKS cluster, it is very simple. Okay, just with a few clicks, we will be able to create the EKS cluster in AWS. And when we are trying to create EKS cluster, one thing we should remember is this EKS is a managed service. That means we don't need to install the components that we have discussed yesterday, either in the control plane or the nodes. We don't need to install. When we are asking for EKS cluster from AWS, AWS will give us the control plane, and by default, every component of the control plane will be installed in this. Okay, so some marriage was going on in the state which I'm living. So the crackers are being fired. If you have any disturbance, please do let me know. Then, when we are asking for Kubernetes cluster means AWS will provide this control plane initially. Later, we will add these nodes, which you will see. This control plane definitely should be running in some server, and those servers we are not going to maintain. It's a serverless solution which is being provided by the AWS. We are just asking for the Kubernetes cluster. AWS will give us the control plane, and later we will be able to add our nodes based on our requirements. Okay, so as of now, let's take our 2 nodes and let's try to create this cluster. So for that, first go to your AWS account, aws.amazon.com is the URL for that. Then sign into the console. I want to log in as the root user. If you are a IAM user, if you have the privileges to create the EKS, then you can use it. So this is my email address. So that's why I always tell that if you want to learn DevOps, please be comfortable with any of the cloud. At least you should learn a cloud. Okay. So this is the front page or the home page of the AWS. Now I'm going to services, and I'm in Mumbai region, and recently Hyderabad region was also launched. If you want to use that, you can register for Hyderabad region. You can use it, but I want to do it in the Mumbai region. Go to services, and in services you can click on all services. Here you can click on view all services. In this, we have compute, containers, and storage, and other services, database services, and all. So in this, go to containers. In this, we have Elastic Kubernetes service, and we have Elastic Container Registry also to save our images. So now let's use Elastic Kubernetes service. So this is the page. When we go to that, then click on this cluster. Then here you can create a cluster. Click on create. Now, what's the name of the cluster that you want to give? Let's give it as demo cluster. Then after that, specify the Kubernetes version. So by default, I want to use this one. Then after that, we have to create a role. In AWS, if you have the knowledge of AWS, you must have the knowledge of the roles. Okay, so how to create that role? For that, we have to go to the IAM section. So I will show the steps so that you won't be confused. This is for the people especially who don't have the knowledge of the AWS. So this is the first step. Then here we have given name to the cluster. Then we have to create a role. Why we have to create role? Because we want to give EKS service to manage the AWS resources. What kind of AWS resources? Like content registry, the EC2 instances, the security groups, and other things. So for that, what we need to do, we have to create a role. So for that, what we do is, I want to duplicate this tab, then go to IAM, search for IAM here. You will get the identity and access management service. Then in this, what we need to do? So go to IAM console. After that, we have to go to role somewhere here. Okay. Click on this roles. After that, we have to click on this create role. Then in create role, so keep this AWS service. Then after that, what we need to do is we have to select what? EKS. So here we are not using this, we are using EKS service, right? Search for EKS, click on this. So in EKS, we have different use cases. In that, we have to use EKS cluster. Okay, so click on EKS cluster as I have shown in the diagram. Then check on this. Then after that, click on next. Okay, so after clicking on next, you will see the permissions which are associated with this policy. If you see that, these things will be there in this. Then after that, click on next. Then here it will be asking for role name. The role name which we have given here is demo cluster role. Okay, so now what I will do is demo cluster role 8 p.m. I'm giving something like this because I think already I have roles created in this. So that's why I'm giving something like this. So this is description we want to. Then in this role, what we have to do is we have to click on create tags. If you want to give some tags like related to dev prod or something like, you can use. Okay, but we are not going to learn all those things here. That's part of AWS. So this role called demo cluster role 8 p.m. got created. Where it is? This is. Then if you are comfortable with Azure, go to portal.azure and you can go to AKS. In that AKS, you have to perform few steps. And with that, AKS cluster will be ready for you. After creating the cluster, everything will be same irrespective of the cloud. Then that role has been created. If that role is created, if we refresh here, that role will be coming here. If that role is not created, and if you are trying to go next, then what will happen? It will throw error saying that we have to choose some role. So now the role is created, and after that it is populated here. We have to select that. Then click on next, keep everything default. If you want to keep this particular EKS cluster in one own virtual private cloud, you can create that and you can give the subnets there. But I want to use the default VPC and the subnets which are there in that particular region. Okay, in Mumbai region, we have in Mumbai region we have 3 not data center availability zones. So I'm selecting all those things. And the security groups, you can use the default security group. Okay, or if you want to block any incoming or outgoing traffic, You can create your own security group and that will be populated here. You can use that. And for cluster, in the cluster nodes and these pods will be getting IP address that the pods will be for pods and services, which you will understand later. We will be getting IP address, and those IP address I want to be in the IPv4 format. And then, so I want to get the public access, so that public access in the sense I can connect from the outside of this VPC, and from my local I can connect to that. So that's why I'm keeping this as public. Then click on next. Then I don't want to select this logging. I don't want to use CloudWatch logs. Okay. If you want to use CloudWatch logs, you can enable these things so that we will be getting the logs pertaining to the cluster. Then click on next. So as a part of AWS cloud, you should learn all those options. Okay. The security groups, VPCs, this CloudWatch and everything. Okay. So I want to enable this service networking within our cluster. This QProx I want to enable. Core DNS will be, so these things will be by default installed by the AWS itself, because we are trying to use the managed service. If you want to use your own, if you want to install your own Kubernetes in your virtual machines, then you can do that by using KubeADM, which we will learn in different section. Then click on next. So this is fine. Then I want to review, then click on next. If you want to edit, you can edit anything. Then after that, click on create. It will take about 10 to 15 minutes, friends, for the demo cluster to be up. So that means the AWS has to allocate a virtual box to us, and in that it will create that control plane. So which will take about 10 minutes. And what we do is, after creating this control plane, okay, so that means once we create the EKS cluster, then we have to add our nodes. Okay, so the steps which we have performed, I have shown in the form of these pictures. You can go to that.
Laxman,
So,
will they charge any amount for this cluster?
Yes, definitely it will charge. It will charge because this control plane will be running in some virtual machine only, right? So for that, definitely it will be costing. So you can search for the cost of this EKS price per hour.
I think what are the VMs we have created earlier for the Docker? That is not chargeable, right? We have choose the.
That is also chargeable, but if you have a free account,
Okay.
creator account for 12 months, some 750 hours of computing will be given free to you. So if you are using those limits, if you are using the free tier eligible instances, then you won't be charged.
Okay.
Okay. So some restrictions are there. So for few services, they will be giving that kind of computing capacity, like that you have to choose. Okay. If you don't have understanding that, please go to some YouTube videos so that you will understand. Otherwise, if you don't know all those things, if you keep the things running, then you will be getting the bills in thousands. And if unfortunately, if you create a machine which is having 30 to 50 GB of memory and about 20 to 30 core CPU, then you will be getting unlimited billing. Okay.
Okay, got it. Now we have created this cluster, right? So assume we have created and we have powered it off. Still we'll get the billing?
We can't power it off. In AWS, we can't switch off it.
Okay.
You can delete it, but in Azure, you can switch off the cluster. You can stop the cluster.
Okay.
Okay. So that's the thing. So it is being created. It will take about 10 to 12 minutes. So meanwhile, you're asking for pricing, EKS pricing. So if that you create 10 $0.1 per every hour. That means somewhere we can also convert this into the rupees. It's not there. Okay, that's fine. So $1 is about 75 to 80 rupees. It is about 80 rupees. So 80 rupees means per hour, approximately 8 rupees will be charged. Okay.
Okay, Laxman. Yeah.
That is the cost. You don't need to worry about that. But nodes we will attach. So nodes are nothing but EC2 instances. And for those nodes will be separately charged. This is for the empty cluster. If you add the nodes, for the nodes, whatever the billing is there for that particular EC2 instances, that billing will be applied. We will see that. Let it be created. Now, so there are two ways to deploy the things in the Kubernetes cluster. There are two approaches. One approach is called as imperative approach. Imperative approach means to get the desired state, we will run one or the other command. After running multiple commands, we will get the desired state. For example, if you want to deploy some Nginx application, first we will create a deployment. After that, we will scale it up to get the desired number of replicas. After that, we will create a service through commands. All those things will be performed through the commands. That approach is called as imperative approach, which I have shown in the Docker. But that approach we don't use. We use declarative approach, where the desired state of our application or our configuration will be written in YAML file. That YAML files are called Kubernetes manifest files or Kubernetes deployment files. And those files are nothing but what? YAML files. And before going to the declarative approach, let's understand imperative deployment approach. So in this, if we want to create a container, an Nginx container in Docker, which command we have used? Docker run. So the name of the container we will give, let's name it as my Nginx. Then after that, what we need to provide the image, something like this at the end. Then we will run this in the detached mode. Then we will perform the automatic port mapping. All those things we will be giving. And if we want to create volumes, we will use volumes. And if we want to pass environment variables, we will use something like this, right? So let's not worry about the options. So this is the basic command which we use to create a container in the Docker. In Kubernetes, what we create, the smallest deployment unit, that is pod. So in Docker is the CLI. In Kubernetes, we have kubectl CLI, kubectl, then run. Then after that, here we will provide the name of the container, name of the pod, something like my Nginx. Here we don't have this hyphen name in this. Then we will provide the image with image equals to this in this format we will specify. So with this you will understand that in Kubernetes also ultimately we are going to create containers. But in Kubernetes, these containers will be wrapped inside a box called as pod. So when we create this, pod will be created, and inside pod, what will be there? Container will be running. As simple as that. So this is the simulate command. So if we achieve this kind of deployment through the command line, then it is called as what? Imperative approach. Then this is to just create a pod, but we don't generally create the pods in this manner. We will use that manifest file, and that too we will use some higher level object which will control the pods. If you don't understand the statement, that's well and good. we will understand that slowly. So let's go and see whether the cluster is created or not. It's not still up. Then once we create this Nginx application, okay, so let me draw that here. This is our cluster. This is our cluster. Then what we are doing? We are creating a pod. A pod consists of what? Container inside it. Okay, this is a container. This is an Nginx application. This pod will get some internal IP address. When I say internal IP address, the application will be accessible only within this cluster. That means other applications which are running in the same cluster can access this particular pod with its IP address. Okay. For example, let's say some other some other pod is also running in the same cluster. Some other pod is also running in the same cluster. Let's suppose that this is the WordPress container and this is MySQL database. We know that WordPress requires what? Database, and this is a MySQL database. So for that, we have to provide the MySQL database host in the WordPress. For that, what we need to do? We have to give the IP address of this pod. And because these two pods are running in the same cluster and that internal IP is observable by one another. So that means this IP address can be pinged from this virtual machine or the pod, and its IP address can be pinged from here. But if it is WordPress, if you want to give access to the public, we should have a public IP address. For that, what we need to do is we have to expose this. We have to expose this to the outer world so that people out of this cluster will also be able to access that. So for that, what we do is we will expose this. When we are exposing means we will be getting some IP address which is externally usable. So that thing, for that we have a command called kubectl expose pod. We want to expose this pod. Okay, how we want to expose? And after exposing, once we use this, an object called service object will be created with this command, and that service object I'm naming it as hello Nginx. Anyway, you will understand that going forward what is service and object and all. I'm just giving some overview what we are going to do. So when we are trying to expose this pod, means we are trying to create some IP address, and that IP address will be created through some service. What is service and what are the different kinds of service, we will understand going forward. And we are naming that service as hello Nginx. And how do you want to expose it? I want to expose it as a load balancer. So that means if we have the multiple pods also for the same Nginx application, the traffic will be load balanced between the two pods. Anyway, you will understand that. I'm just describing the imperative commands, how they will look like, but all these configuration things we will be writing in the YAML files. And
so this expose command is Kubernetes specific or EKS specific?
Kubernetes specific. Once you create the cluster and once we get the credentials of this cluster, we have to forget everything. So whether your cluster is in Azure, whether we have created our cluster using KubeADM or EKS or GCP, anything, every command will be same. You got my point, right?
Okay, and as you mentioned, this will create a service, and dash dash tap is equal to load balancer we mentioned. What are the other types
I
for
will
service?
tell you that. I will tell you that.
Okay.
Okay, we have different kinds of services.
Uh,
Okay, we have a dedicated section for that. Very important thing. We will understand that thing. So now we will move on to create it because the cluster is being created. So I'm telling those things. Now the cluster is active. We have to add the nodes to that. Yeah, somebody is trying to ask some question. You can go ahead.
yes. Hi, Lakshman. So,
Hmm.
sir, I just wanted to ask the pod IPs, right? The pods which are created inside the Kubernetes kube cluster.
Hmm.
Those pod, does it have a static IP or dynamic IP? If let's say one pod has to internally communicate to other pod, right, in terms of data transfer, then in that case, we have to specify a respective pod IP, static IP in the configuration file.
Very good question. Yeah, very good question. So in Docker, are you part of this Docker course? No,
Uh,
right?
n- no, sir. I directly
Okay,
joined
yeah.
Kubernetes. Yeah.
So in the world of containers, we don't use the IP addresses because if you deploy some application, we don't deploy a single replica. Instead, we will run the same Nginx application in 5 instances. And 5 instances means 5 pods.
Okay.
Are 5 replicas, and those 5 replicas will be running the same application in 5 instances. Friends, I think you lost me, right?
Yeah, your voice was not
Yes,
audible.
Lakshman.
Unfortunately, God, but I don't know what happened during the nights. The internet is not working properly. Sorry. Now, is it fine? Let
Yeah.
me switch to different network, but it's very bad thing. It should not happen. Okay. So in the world of containers, we don't rely on the IP address. Why? Because the same application will be running in multiple replicas. And which IP address we need to give for some service to access this? Conflict will come. So what we do is combinedly we will create an object called service, and that service name or the internal domain name will be created. We will use that in that particular service which wants this service to be accessible. You got my point, right?
Yes, Lakshman. I got it. Thank you.
Okay. Then so let's proceed with the creation of this nodes. So this is the cluster that is created for us. So these are the details, API server endpoints and other cluster AR and certificate authority. All those things are given here. Now resources. So if you see any resources, we are seeing 2 pods, but they will be in some stop state because they are not ready. They are part of the deployment. Okay, we will see through the command line. Deployment of the cluster, I mean to say. Now go to compute. In compute, we will add these nodes, and this is ready for us, and this is given by the Kubernetes AWS itself. And now once this is given by the AWS means some servers were given to us behind the scenes, and in that the components which should be there in the control plane will also be given to us. So totally it is given to us. Now we have to create these things. So for that, in this, click on add node group. Then after that, we have to give the name to the node group. So when we are going to add node groups means we can create multiple node groups. And in each node group, you can specify the type of instance. For example, you can create 5 node groups. In one node group, you can take the instances which are of about 4 GB memory. And in second group, you can take instances which are of having about 8 GB memory. So that way you can take. But it's good to have only a single node group. In real time, it won't be that complex. We need to have a single node group only. So in node group configuration, in extreme cases, if you have the requirement that all the nodes should not be the same in size, then in that case, you can create multiple node groups. And in each node group, you can have the instances of a same size. In one node group, you can have 8 GB memory instances. In another node groups, you can have 4 GB memory instances. In other node groups, you can have instances or the nodes of 32 GB. Like that, you can choose. Now, let's name this as demo node group. And we will be getting some doubt how we will be naming them in the real time. You can name something like dev node group. And if you want to give the region also, you can give the region. For example, Mumbai also can give, or the ID of the Mumbai region, you can give AP South one, something like, or US West, US East, something like you can specify. Okay. So, but I'm here specifying this as something like demo node group. Then in node IAM role, again, these are populated because I have already created them in the earlier session. And now we have to create it. But if you don't have the roles related to the node group, we have to create. How to create that? Again, go to IAM, click on role, click on create role. Then here, see, I have given the thing. So just now check EC2 because we are going to use the EC2 instances as the nodes. Then after that, you have to add permissions. Add permissions here. So this is EC2 as the use case. Then in these permissions, which permissions and policies we have to add? So here, one thing is in filter find field type EKS, it will give some list.
Laxman, which service did you select? After selecting the EC2, which below we have this use case for other AWS service. Did you select anything there?
EC2.
EC2. Oh, okay. Yeah. Okay. Below that, you didn't select anything. Yeah.
Yes. If you want other things, that list will be here.
Yeah.
Click on next. Then search for EKS here. So once we hit enter, it will show these things. So out of these things, we have to choose Amazon EKS worker node policy, Amazon EKS worker node policy, Amazon EKS CNI policy. And what are these policies, permissions, this IAM role you must learn as part of AWS. So here my desire is to create some cluster so that we will learn the Kubernetes. And if you don't want to use this, you can use the Minikube also, but that is single node cluster which doesn't reflect the real-time scenario. So that's why I'm trying to create some real-time situation. So that is fine. These two we have to select. And after that, we have to choose one more thing also. Because if we want to use Elastic Container Registry service of the AWS, we have to give permission to that as well. For that, what we need to check, we have to add this policy also. What is it? Amazon EC2 Container Registry read only. Okay, so how to add that? So if you see that is not there in this list, so let's search for that. So let's clear it. Now, what's the policy name? Amazon EC2 container registry. Let's search for container registry. So Amazon EC2 container registry read only is fine. If you want to give full access also, you can give. Then click on next. Okay, do we need to any other policy? I think no. Okay, so total how many permissions we have given? Three policies. Then here give the role name. So it seems like already I have role name with 8 p.m. Let me delete that. No group role. I want to delete that. If you want to delete, you have to delete that something like this. Confirm that by typing the same thing in this box. Then delete it. That's fine. Now let's do the demo node group role 8 p.m. Something like I'm giving. Then after that, if you want to add any tags, you can do that. Otherwise, you can just create role. So that role has been created. And in this, if you go and check, that role will be there here. Okay, this one. Demo node group role 8 p.m. What is it? Delete this as well. I also want to delete these things because I no longer use this. Let's use this 8 p.m. things throughout this course. So just because we are trying to delete two resources, you have to just use the delete there. So that's it. So now if you refresh here, so that role group IAM role will be shown here. And this is the thing that we have selected. Then these terms and tolerations, these labels we will understand. These labels and terms and tolerations we will give through the commands if we want. Okay, and if we want to this you will understand during the course. Then only it is up to you to enable this or not, to add them or not. That's fine. Click on next. Then the main thing comes here. AMA type. AM means Amazon machine image. Okay, so what kind of operating system that you want to use? Let's use Amazon Linux only. If you want to use Windows Server, others, and these are the things that are being provided by the AWS. So let's choose Amazon Linux to this thing and this architecture on the 64-bit machine. Then capacity type, I want to use on demand. If you want to proceed with Spot, you can use the Spot instances. Okay, so you must be knowing what is Spot, on demand, what is reserved instances. Then instance type, what kind of instance you want to use. So that means the CPU and memory amount of CPU, memory, and the network speed that you want to use. See, if you unfortunately if you select this first one, it will consume lot of your phone. That means it is built very heavily. So 60 GB instance is also available. 192 GB is also available. Okay, so different combinations of memory, CPU, and network are available. But let's go with T2 dot. T2 dot micro won't be available in this. Let's use T2 dot medium. Okay, T2.micro is also available, but you will be having only, you can run only few instances, which doesn't suffice for the situation. So let's use T2.medium. Okay, but in real time, based on the number of applications that you want to run, the intensity of the applications, that means how intense they are, how intensely they can consume memory and CPU. Based on that, you will choose the instances. But in our current projects, so we are using this T2.2XLR. Okay, so that's the thing. So I have selected this. Then disk size is 20 GB is enough for us. So here, if you see node group scaling configuration. So desired size, set the desired number of nodes that the group should launch with initially. How many nodes that you want to launch initially, that number we will specify here. So minimum means set the minimum number of nodes that the group can scale into. Okay, so scale into means minimum size means the minimum we want to have 2 nodes with respect to whether the load is there or not in the cluster. And maximum, even if the load is very high, the load is increasing, I don't want to go beyond 2 nodes. So that's what we are specifying here. Okay, this is something like auto scaling configuration, which you should learn as part of AWS. But this is the minimum, this is maximum. And we can keep in real time, we can keep this as 15 or 10 or anything. Okay, so let's keep it as 5. In our current projects, we are keeping this as 15. We are keeping this minimum as 5. So that means that irrespective of the load condition, always 5 instances will be running. That means 5 nodes will be there in my cluster. And as the load is increasing, so that can be measured with the CPU and memory, the number of instances will be automatically added up. And when the load is decreased, they will be scaled down. Okay, maximum unavailable in case of update configuration. So when we are trying to update the nodes, how many nodes you want to be unavailable? How many nodes you want to update at once? So I want to update it as 1. Okay, so I'm using the same default setting. If you want to SSH into the nodes separately, for some reason you can enable this. Okay, but I don't want to do that. And click on next, review the things, then click on create. This, what will happen? These nodes will be created, and initially we want to launch 2 nodes. And these nodes are nothing but what? EC2 instances only. So node group creation in progress. So now it's being created. It will take several minutes. It won't take more than 3 to 4 minutes. It is just a creation of the EC2 instances. So those things will be coming here. And some auto scaling group will also be created. Then, so let's duplicate this tab. Otherwise, let's use this one. Go to EC2 dashboard. Okay, so as a part of this, an auto scaling group will be created. Then for each node, volumes will be created for sure. And so one node is created and it is up and running. Other will also create. Let's wait for it. And you can't SSH into this because we did not enable the SSH as of now.
So Laxman, when we are creating the EKS cluster, so what is suggested to use as a storage? Is it like EFS or the EBS volumes?
You mean to say persistent volumes you're talking about?
Yes.
EFS.
EFS. So that thing we define now itself or later when we will be creating the manifest?
That if we want to use the persistent volumes, we will create that. But the storage means the general storage that is attached to the EC2 instance. That storage.
Those are the EBS volumes.
Things. Yeah. Okay, these are EBS things only.
Yeah. So that persistent volumes that we will create separately. Right?
Yes.
Okay.
So other node is also being up. It is in pending state. We go and check here because this is not completed. We will see the same status. Come to nodes here. See, one node is up. It's ready, and other node also should be created. Will take 2 to 3 minutes. And now the thing is, this cluster is there in the AWS cloud. This cluster is there in the AWS cloud. But you have installed your kubectl in your local machine. We have installed our kubectl in our local machine. This is there in the AWS. Okay. Now we have installed kubectl in our laptop, which is local to us, and this cluster is remote. It is in remote location, that is in AWS, and we have installed kubectl in our machine. Okay, and how to authorize this machine to access this cluster? For that, there is a file, there is a configuration file which will be there for every Kubernetes cluster. That file is called as kubeconfig file, which stands for Kubernetes config file. And that file will be downloaded only after we authorize to the cluster, we authorize to the AWS account from our local machine. How to do that? For that, first we have to install AWS CLI. First we have to install AWS CLI. Why? Because first, this is in AWS cloud. This is in AWS. This cluster is in AWS. Okay, this is AWS. First, we have to connect to this AWS from our local machine, and that can be done using AWS CLI. And once we connect to this, the next step is, after connecting to this, we have to connect to this one. So in order to access this, first we should be able to access this AWS. For that, we have to provide the credentials here. How to do that? So for that, first we need to install AWS CLI. How to install AWS CLI? Just copy this. So this file will be generated. So once that file is downloaded, double click on that, confirm the installation, then open the start menu, then go to command line interface, CMD. Okay, so once we go to CMD, let me go to my Visual Studio Code. I'm using my Visual Studio Code. Okay, this is the Visual Studio Code, and I don't want to use the CMD. I want to use the CMD which is provided in the. This is also same thing only here. So I'm opening the PowerShell here. Then I'm confirming whether kubectl is installed or not. This is installed as. Now we have to install what? AWS CLI. Okay, and once we click on this, it will be asking for confirmation. You just click on next. You know very well how to install those things. Then see that AWS CLI is installed. Then kubectl we have already downloaded. Then what we need to do is, first, how to connect to this AWS? For that, we have a command called AWS configure. This is the command. Enter this, it will ask for where AWS access key and secret key. How do we provide that? If we want to connect to AWS console through a graphical user interface, we will give the username and password, right? That's what we have done in the beginning. But through connect to the to connect through AWS CLI, we have to provide the AWS access key and secret key. So for that, where we will be getting that, click on this, our account ID name, then click on security credentials. This is especially for those who don't have the knowledge of the AWS, but still they want to create cluster in the AWS. So that's what I'm taking the support. Then here, somewhere, see, here we have access keys portion. Here, click on create access keys. Then I understand, okay, risk that is associated. So create access key. Access key has been created. We have to download it because once it is created and it will be shown here, but after that, you won't be able to get that from here if you want to use the same thing. So first we have to download them somewhere in our local. So we can download it, click on this and continue. We can download, but I don't want to download it. I just want to give the access key. Then secret access key. What is it? This is the secret access key. Then default region, yes, AP South 1 is the default. I want to keep that. Then default output format, that is JSON. By default, I want to keep it. Then this is fine. So now what we have done from our local machine, we authenticated to AWS, but we have to authenticate to the cluster as well. How to authenticate to the cluster? And you may be getting some doubt that why we need to explicitly authenticate to the cluster when we have the access to the whole AWS. That may be your doubt. But in the same account, you may have about 10 cluster, 10 Kubernetes cluster. For example, 3 for dev, 3 for some QE, then some for prod, something like that. So to which cluster we have to connect through this kubectl? That information also should be very specific. How to do that? For that, we have to get the configuration file, kubeconfig file of that particular cluster. If we have 3 clusters in the same account, for every cluster, you will be having a kubeconfig file. So I want to get the kubeconfig file of this cluster. For that, what we need to do is we have a command called AWS EKS --region. So the region name in whichever cluster is there, we have to specify that and update kubeconfig. That means we want to update the kubeconfig, which is already there in our local machine. Okay, some kubeconfig will be there in our machine. We want to update that. Okay, but if any kubeconfig is already not there in our local machine, kubeconfig will be created. I will show you. Then what is the name of the cluster out of those 3 clusters? So the name of our cluster is demo cluster. So that we have to specify. So finally, what I will do is, this is the command that I should execute. What will happen when we execute this command? When we execute this command, kubeconfig file, which is related to this particular Kubernetes cluster, will be downloaded into our machine. Okay, where it will be downloaded. So for time being, I just want to check. I will enable screen share. Wait, friends. That's fine. No worries at all. No, that's not fine. I'm just trying to hide some confidential information. Nothing more than that. Now to hide it. Okay, I don't know whether it is hidden or not, but I don't bother about that. Very sensitive information I have. So first, what we need to do, we have to execute this command. We have to execute this command. So I'm trying to execute this. This is the command that I'm executing the AWS EKS. Where is our cluster? Our cluster is there.
Laxman, can you remove this media player from your screen?
Let it be for some time.
Okay.
AP South one. I don't know how to hide the information.
Okay.
Update kubeconfig hyphen name. So demo cluster. So I'm hitting this. When we hit this, what will happen is, so this directory I'm deleting. I'm deleting that directory. That's fine. So what will happen is, when we are trying to, when we execute this, here .cube folder will be created. Where it will be created? It will be created in the C drive. It will be created in the C drive. So I'm into the C drive. Let's execute this. Once we execute this, still I'm not able to manage those things. So here .cube directory has been created. Now, if I click on this, see some config file has been created here. So when it was created just now at 9:04, it was created. Now let's open this. Okay, so this is the config file that is created. Now see what is there in this, the cluster certificate, the cluster and all those things, the cluster name. So this is the file, or in crude terms I can say that this is the file which consists of the credentials about this particular cluster. And if we have another cluster, for that particular config file will be there. Okay, so something like not a particular config file will be there, the same details will be updated here. Okay, and you can try to create two clusters and you will see how those things will be reflected here. So that's fine. Now we got that particular file. That file is created where? That config file is created in some directory called .cube, which is there in the C drive. If the .cube won't be there, initially that won't be there, the .cube directory will be created, or the folder will be created. In that config file will be downloaded. Now this kubectl command line interface, this client will be able to read that config file which is there in that location. So that means that config file should be there in this path only. In C, it should be there in C .cube and in that config. If that config is there in that particular location, then only this kubectl tool can read that file. If so, that's why when we execute this command, by default that file will be generated there only. But After some time, if you try to copy this to somewhere, and in that case, this kubectl command line won't be able to read that if it is not in this location. Okay, so that's fine. So now just to 3 minutes, friend, we will close this session. Now we connected to the Kubernetes cluster. Then let's see. Let's see some commands, 1 or 2 commands. Do that. Trying to move it a little bit lower. I want to know the cluster information, kubectl cluster info. When I tell kubectl cluster info, which cluster information it is giving? This cluster only. Why? Because we have that file in this location. So we have one and only one cluster, and that cluster details are there in this config. So we will be getting the details about that. If we have multiple clusters and the details will be appended to the same config file, then in that case, how to switch to multiple clusters, we will see that. So this is cluster information. This command, just I want to check where are we in this. So we are into the demo cluster. Where it is show. This is the URL. This is not exactly the. We have another command, a config command. I will tell you. Kubectl config current context. So this is the demo cluster, is the current cluster. Now I want to see the number of nodes in our cluster. Okay, in our cluster, kubectl get nodes is the command. See, we have 2 nodes, and the rest of the things we will see tomorrow. So today we have seen how to create the EKS cluster in AWS, and tomorrow when I am coming to the class, I will create the cluster beforehand, and we will try to start from here. That's it for today, friends. Let's meet tomorrow. Thank you. If you have any questions.
So you deleting this cluster now?
Yes, I will delete. Let me show how I can delete. I'm going to delete it because I no longer use this. So some people, what they will say do is they will create the EC2 instances. Okay, you should not create something like. Why? If you create that, again they will be created. So first, what we need to do is, if we want to create your own, delete your own whole cluster, go to the Elastic Kubernetes service. There, first you need to delete the node groups. Okay. Otherwise, let's try to delete from here. Confirm this. Okay, cluster has node groups attached. You can delete node groups at the cluster's compute tab. That means when the node groups are attached to the cluster, we can't delete the cluster. First, we need to delete the node groups. So go to compute section, and here we have the node group section. Click on this delete, then copy that here, confirm it by pasting it here. So it will take 1 to 2 minutes for the node groups to be terminated. I think it will take about 5 to 6 minutes, 7 minutes around, to be more precise. Then once this node group termination is completed, then only we will be allowed to delete it. Otherwise, it won't be enabled. Okay, so this has to be committed. So total. So once this is deleted, then once it is enabled, once node group is terminated, then once it is enabled, you can just click on this and delete. You can close the account. Okay, you can close it. In the background, it will delete. You no need to wait for the demo cluster to be deleted. Just you have to click delete. Once you have clicked the delete, it will tell that demo cluster is being deleted. The status you will get, and you don't need to wait for that. You can close your things and everything. That will delete everything. Okay, so first we need to delete the node group. Once we deleting the node groups means these instances will be deleted by default. See, these are being shut down. Okay, friends, let's meet tomorrow.
Hi, Laxman. I just have to ask last query. Hello.
Mm.
So on this Q cluster, if you want to deploy Kafka instances or let's say MQ instances, then how to do it?
Yeah, for that you will be having the Docker image for that MQ, right? For example, if you take Rabbit MQ,
yeah,
if you go to Docker Hub, if you search for Rabbit MQ, okay, see this Rabbit MQ is there.
Yeah.
You will use this in the manifest file, and you can run the Rabbit MQ, and for that we will create some service so that this Rabbit MQ is accessible over the web.
Oh, the web. Okay. Yeah.
Okay.
Yeah.
And after learning the deployments and the pods, you will learn how to create this by your own. Okay. You will get to know that for sure.
So when we are pulling this image, where the Docker comes in picture in a pod?
These nodes will contain Docker, right? That is the main component.
Okay.
Yesterday architecture you forgot?
I actually missed some of the thing. I will go through it now.
See, every node consists of Docker.
Yeah.
So ultimately, the
got
pods will be created in the nodes. So pods means the containers will be created in the nodes. Container needs what? Docker image. And that Docker image will be pulled from the Docker Hub by default. If we have any private registries, then we have to specify the credentials and all those things in the form of secrets, which we will learn also.
Yesterday, actually, we had some production issue at the time of training. So I was stuck there.
Okay, no issue. So please go through the yesterday's one.
And Laxman, like yesterday video is there only in YouTube. It is not there in our Google Drive.
Okay, I think then they will create some other folder inside that 8 p.m. folder, and there they will upload that. I will let them know after this meeting. I will call them. I will ask them to create that thing as well. And somebody is asking for notes. I will upload that notes for time being in the Docker thing itself. And tomorrow, once they create that, then I will also upload that notes there. Okay, you will find the notes in the on Docker thing. Okay.
Sure.
Thank you, friends. Let's meet tomorrow. Bye.
Bye-bye.
Yeah. Hi, Laxman. I wanted to join this course. Hello.
Oh yes.
Yeah. So I have to contact DURGASOFT admin people, right? Directly.
Yes.
And okay, then I would like to continue with Docker, learning Docker as well. So let me contact them. We'll get info. We'll have to pay the fees. How much is the fees, by the way, for this course?
Just for Kubernetes, it is 2,500. For whole course, Docker and Kubernetes, it is 4,000.
Yeah.
And in case if you want to get the Docker classes also, you can you will ask them. Okay, you ask them, they will tell the fee, and by that you can go through the Docker recordings as well. Otherwise, if you are comfortable with the Docker, that's fine. You can pay for this Kubernetes itself.
Yeah. Okay. Got it, Laxman. So no, after completing this course, would like to separately learn Docker. Okay. And yeah, let me contact DURGASOFT.
Okay, sure.
Okay. Thank you.
Thank you all. Bye.
Thank you. Good night. Bye.